Okay, welcome to the back envelope where we're going to talk about area of triangles, and I'm kind of this is my first one, so please bear with me. The triangle, you may have, well, let's just talk about a rectangle. So a rectangle is a four-sided polygon. It has four right angles, and it's the area. To find the area, if this length is B and this length is A, area is A times B. Alright, all good. And now, what if you have a triangle? How do we find what a triangle is, area? So, what if we cut the rectangle in half? Now, you could cut it in half this way, and if it was exactly in half, this region and this region would both be half of the original area. Or you could cut it in half this way, and then the top region and the bottom region would both be equal half. So what other ways could we cut it? Well, what about this way? And I have an example like this, and sure enough, both halves, both are triangles, both are half of the original, and so that's what we're dealing with. Now, what we have here is we have this triangle here, this right triangle, we know is half of the rectangle. So the triangle area is 1/2 A times B. So, alright, but not all right triangles are, not all triangles are right triangles. You have, you know, this, or even this. So, well, how do you figure that? Well, let's look at this one here. What if we draw a line, a right angle to the base? So if this flat part is the base, B, if this is distance here is B1, and this one here is B2, and then this height or altitude, A is altitude. Well, we have the left triangle. Area is 1/2 A times B1. And then the right triangle, well, the right side of the triangle, area is 1/2 A times B2. So we can add those two areas together to get the area of the entire triangle. Well, pull out, do some rearranging, distributive property, whatever you want to call it. You can get 1/2 times A times B1 plus B2. But we already said that B1 plus B2 is equal to B. So now for a non-right triangle like this, we have the area is still 1/2 A times B. So that's great. What about this leaning over triangle here? What What's going to happen there? How can we prove the area of that? Well, let's take, it's going to be a little bit trickier, but we'll take this little dotted region. Now, we have the big triangle, and we'll call this big B for the big base. And then we still have this A right here, which is the altitude. The altitude's always at right angles to the base, by the way. So we know that the area of the large triangle is 1/2 A times B, big B. Now, but we want the small, we want this one over here. So what can we do? Well, if we look and say, well, wait, here's another, we had this big triangle as a right triangle, but also here's a smaller right triangle. Well, what's the base of the small right triangle? Well, it's B minus B, big B minus little b. So the area of this smaller triangle is going to be one half A times B minus B, big B minus little b. So now we have, this is the whole triangle, well, the imaginary part plus, and then this part is just the little imaginary triangle. Well, we don't really want that part. We only want our triangle. So we're going to take the whole triangle, subtract off the small right triangle, and we will have, and what I'm going to do, I'm going to, at back envelope, we don't use just the back, we use both sides. Now there's some printing on that over there, so I just folded it. So we're going to have sorry, this is what we have now. We have, this is the big triangle, this is the part that we don't want. We want to subtract those, and we're going to have doing some factoring out the A, or we're gonna, and the 1/2, we're going to have 1/2 A, and then we're going to have B minus B minus B, and then that is gonna rearrange, and we're gonna have plus a negative B plus B, and then what that's gonna do, B plus a negative B is just 0. So we have 1/2 A times B. And then that's the first lesson. Hope you liked it, and there'll be more to come.